JavaScript is a single-threaded language. If you're not familiar with the concept of thread, here's a quick 1-minute explanation. So we can run a lot of processes in a computer, and each process could contain multiple threads. Having multiple threads simply means that the process can run multiple things at once. Now, JavaScript being a single-threaded language simply means that JavaScript can only run one thing at a time. And that's exactly the reason why sometimes you will see some website got stuck on something and enter a perpetual loading state. That's most likely because the JavaScript in the browser was busy processing an operation and could not load the other things. This scenario is often what we call thread blocking, and is super bad for the user experience. Well, does that mean JavaScript is a shit language? It depends whether you use Stack Overflow or not. Anyway, traditionally, JavaScript developers can solve this by using asynchronous programming. That is, to run the expensive operations in the future. For example, using features like promises in our code. But sometimes asynchronous programming is still not enough to satisfy our need. We need something that's more powerful so we can get more juice out of it. And that's where Service Worker joins the big picture. In short, Service Worker is another thread in a browser that runs behind the scene along with the main thread. In general, we use Service Worker for two main things. The first one is to run background tasks. Since Service Worker is a second thread in a browser, we could use it to offload some operations from the main thread so the task in the browser can be executed in a more efficient way. For example, in a mail app, we can use Service Worker to fetch any new incoming messages from the server in the background and send the user a push notification if necessary. Now, the second use of Service Worker is to enable offline capability in our web app. At this point, you might be wondering, hold on a minute, did you just say a website that can work offline? Well, that's exactly what I'm talking about. You see, people today are glued to their phone. If you are riding on any train, metro or subway, you'll most likely see people scrolling through their Twitter, Facebook, Instagram, TikTok, and hopefully not Tinder. People just want to use their app and stay online all the time. However, it's not always that we have access to the internet, especially when our ride is going through a tunnel or places with limited internet connectivity. As an app developer, at times like this, we wouldn't want to show our user a big fat error page when there's no internet. That would put a lot of people off and leave a very bad user experience. A better way to handle this is to still load the page, but to show them a notification saying that they don't have internet connection, and the user is still able to see all the data that has been previously loaded in their app. The app should still work offline, it's just without fresh data. You see, traditionally, this is not possible in a website. In a traditional website, the browser relies on the internet to grab data from the server. If there's no internet, the whole website will break down. However, things changes with the introduction of Service Worker. You see, another property of Service Worker is that it is able to intercept all the outgoing and incoming HTTP requests between the browser and the server. In other words, Service Worker is served as the middleman between the server and the browser. But what implication does this middleman bring to us? To answer this question, let's start from the very beginning. Let's say we're visiting Twitter. Now, upon visiting the website, our browser will send out a GET request fetching all the tweets. The request will go through our Service Worker, and the Service Worker will relay our request to the server. The server will then send back a response, which will then pass through Service Worker again. And here is where the interesting part begins. Since the Service Worker is able to access the response, we can write a function in the Service Worker to store the response inside our browser as a cache. There are a few locations in the browser that we can store this cache, either in an IndexedDB, cache storage, or local storage. If you're not familiar with IndexedDB or cache storage, don't worry, we'll go through them in details in the later parts of this series. For now, you can think of IndexedDB and cache storage as the superior version of local storage. Local storage can only store string data, but IndexedDB and cache storage can store things like videos, images, binary data, or even HTTP requests. So the point here is that Service Worker is able to cache our GET tweet requests in the browser storage. Once the data is cached, then Service Worker will finally send the server response back to the browser. So basically, all the HTTP requests will have to go through this procedure, and Service Worker will cache them all. And now, let's look at what will happen if we go offline. We are still in the same scenario where the user tries to send a GET request to get all the tweets from the server. The browser will try to send out a request, and the service worker will attempt to relay the request to the server. However, this time we have no internet. The service worker will obviously receive an error response, but now we have a fallback. If service worker receives an error from the server, then service worker will try to find the old data that has been previously cached inside the browser storage. If the service worker managed to find one, then the service worker will send back the response to the browser, as nothing has happened. If not, it will send back an error. So in the perspective of the browser, since we're getting a valid response back from the service worker, it seems like we're still online. And that's how a web app can work offline with the help of service worker. And remember, since we can put files inside the IndexedDB and cache storage, even if we are offline, the browser is still able to get the necessary HTML, JS, and CSS files from the cache with the help of a service worker. So in theory, we can use service worker as a mock HTTP server. It is possible to write a web app without an actual HTTP server. We just need a service worker that will handle all the outgoing HTTP requests sent out by the browser and keep all the data in the local browser storage. Although service worker is great and powerful, it gets very technical with the implementation. In the example that we went through just now, we talked about how to handle offline GET requests in a web app. But things get super messy when the user tries to create a new tweet or update an existing tweet while they're offline. Getting these operations to work correctly is not a simple task, unfortunately. We'll need to write a lot of code to achieve this. But don't worry, I'll teach you everything I know about this business in this series, and how to write your own offline-ready PWA. Alright, key takeaway for this lesson. JavaScript is a single-threaded language. In other words, it can only do one thing at a time. Service worker is a secondary thread in a browser. With the help of service worker, we can now do two things at a time. If the workload in the main thread is too heavy, it is possible for us to offload some of them to the service worker. Service worker can intercept any outgoing and incoming HTTP request, and we can use this property to write offline web apps, where the service worker will serve as a mock HTTP server. IndexedDB and cache storage are superior browser storage engine that can store images, videos, binary data, or even HTTP requests. That's it for now, and I'll see you again in the next video.